Today we are going to discuss about the components of the thermal power plant, or the simply is represent for the equipments of a steam power station. Generally in the thermal power plant, the major component is coal storage plant, coal handling plant, hash storage plant, hash handling plant, boiler, superheater, economizer, air preheater, turbine, condenser, alternator, exciter. These are comes under for the major component in the thermal power plants. But the coal storage plant, coal handling plant, hash storage plant, hash handling plant is the separate section. That is, once we are importing the coal from the coal mine by railways, roadways, or seaways, we are unloading the coal, and after that we are unloading the coal. We can prepare the coal with the help of the coal pulverization, that is the crushed into small pieces or powder by using ball mill, hammer mill, ball and then bowl mill. Once the coal is burning in the boiler furnace, the output, that is 30 to 40% in terms of unburnt fuel or hash, that is collected in the hash handling plant. After that, the hash storage plant, it should be send it away from the power plant every weekly once or 15 days once. Now, that is the the component of the thermal power plant, or it is represent for the equipment of the steam power station. The primary thing is nothing but the steam generating equipment. The steam generating equipment comes under for boiler, superheater, economizer, air preheater, and electrostatic precipitator. This all comes under for the steam generating equipment. In that, the first one is nothing but the boiler. Boiler is nothing but a closed vessel in which water is converted into steam by utilizing the heat of coal combustion. By utilizing the heat of coal combustion, that is in the boiler, it is a closed vessel. The water is converted in the form of steam by using the fuel, that is the coal, as in the boiler furnace. Here the generated steam is high pressure and then high temperature. That steam drives the steam turbine, which converts the steam energy into mechanical energy. But here the requirements of the boiler is, the boiler, the weight, it should be light in weight. Due to that, the transportation is simple, and erection is also very easy. Suppose if the boiler weight is high, means the transportation is difficult and the erection is also difficult, and the space requirement should be less. We are choosing the boiler, the space requirement, it should be less, and installation must be simple. The space requirement is also very less, and the operation of the boiler must be uninterrupted. It should be highly reliable. Actually, in the thermal power plant, based upon the temperature, we are generating the power. Actually, the water is converted in the form of steam with high pressure and then temperature. Due to that, we are generating the power. In the thermal power plant, the temperature is maintained for 250 degrees centigrade to 500 degrees centigrade. 250 degrees centigrade to 500 degrees centigrade. That is, the minimum temperature is 250 degrees centigrade and the maximum temperature is 500 degrees centigrade. If uninterrupted, we are choosing the uninterrupted boiler, means always the temperature is maintained for constant. Suppose if the boiler is shut down for half an hour, again the temperature is fallen, again we want to bring it to this actual temperature, it takes the minimum time period, either half an hour or 1 hour. Already we know that the conventional power plant is continuous and constant power generation. Continuous and constant power generation. In a day, 24 hours we are generating the power and maintain the throughout the period the constant power generation. These are the various requirements of the boiler. The primary thing is we need to produce quality and then quantitative requirement with minimum cost. The boiler you are choosing is nothing but quality and then quantitative with minimum cost. Another one, the weight should be very less in weight. If the weight is increased, means the transportation is difficult and the erection is also difficult. We are choosing the boiler, the erection is simple and the maintenance is also simple. The space requirement is less. The space requirement is less. These are the various requirements of the boiler. And coming to the classification of boiler, in the thermal power plant, the boiler are classified for two types. One is for water tube boiler, another one is for the fire tube boiler. The thermal power plant, the boilers are classified for two types. One is for water tube boiler, another one is for the fire tube boiler. This diagram is represent for the water tube boiler. This is the first one, and the second one is represent for the fire tube boiler. In water tube boiler, water flows through the tube and the hot gases of the combustion flow over this tube. Now you can observe here, in the tube, the water is flowing inside the tube, surrounded the fire is there. The surrounded the fire is there. But throughout the universal, from all the power plant, they are prepared only for the water tube boiler. Actually, there are two types of boiler is there in the thermal power plant. The classification, one is for the water tube boiler, another one is for the fire tube boiler. In water tube boiler, the water is flowing inside the tubes. The water is flowing inside the tube, surrounded the apply for the fire. Due to that, the efficiency is more. Another one requires less space, and the output we are getting for more efficiency. Now you can observe here, the surrounded the fire. Due to that, the water it's bring from the temperature is fastly. The temperature carried the fastly. And another thing, here we are applying the in the boiler furnace. One is nothing but the fuel, that is in the thermal power plant. The fuel we are using for coal. The atmospheric air to burn the fuel fastly. Another one, water. The water we are using in the boiler. Whenever the fuel is burning, the atmospheric air is entered. Automatically, it should be burned for fastly. It should burn for fastly. Due to that, that is the air and the fuel is inlet. That is atmospheric air is we are given for the inlet. It is carried from the forced draft fan. That is air preheater. It should be supplied from the boiler furnace. The boiler furnace. Whenever the boiler furnace, the coal is burning, that is, this is nothing but the combustion chamber. In the tubes of the boiler, this is nothing but here we are using for the water tube boiler. The water is circulated inside the tubes. The water is circulated inside the tube, and the fire is surrounding. Due to that, this water is converted in the form of steam. The water is converted in the form of steam. This is nothing but the generated steam with high pressure and then temperature. If directly this steam drives the steam turbine, the turbines are damaged. The turbine blades are damaged due to the small amount of the wet particle is there. That is in that vapor, small amount of the moisture particle, the water particle is there. If directly the steam drives the steam turbine, the turbine blades are damaged. To avoid that one, we are using for superheater. We are using for superheater. Here in the flue gases, that is the wastage of the flue gases is there. These flue gases, we can use it reheating in the superheater, economizer, and then air preheater. Again, once the water is continuously, the steam is generated in a 24 hours. In a year, 365 days, the water level it will be reduced. Again, we want to pour the water. This is nothing but the water inlet. The water is carried from the fed water through economizer. The fed water pump to the economizer. Now, this is here. The advantage is nothing but they requires less space, and the efficiency can be maintained throughout the period, and the efficiency is also more in the water tube boiler. The water tube boiler. And one more thing, the construction is very, very simple. The water tube boiler, and the efficiency is maintained from 85 to 90%. In the water tube boiler, the efficiency is maintained from 85 to 90%. And in this, the water tube boiler always maintained for the same temperature, because here the surrounded the steam is the fire is there. The water is circulated inside the tubes. And another thing, the steam pressure of the water tube boiler is unlimited. The steam pressure of the water tube boiler is unlimited. These are the various advantages. Coming to the fire tube boiler, this is nothing but the fire tube boiler. In fire tube boiler, the hot product of the combustion passes in the tube surrounded by water. Surrounded by water. The fire tube boiler, the another name is nothing but the tubular boiler. The another name of the water tube boiler is nothing but tubular boiler. Tubular boiler. Here, this is the very simple for visible and the rugged construction, and the initial cost is also very, very less. You can observe here, this is nothing but the furnace. This is nothing but the boiler furnace. In that the furnace, the steam, that is the fire is burning. inside the tube, inside the internally the fire is burning, the surrounded by the water, surrounded by the water. Due to that, the main drawback is the steam outlet, it will be very less. The steam outlet, it will be very less. Whenever the water is injected, if internally fired means the surrounding the water, that much of the fire is not sufficient. To maintain the constant, always constant. To maintain the temperature constant always. Here, the steam production is less. In this, the fire tube boiler, the steam production is less, and it's not suitable for the large power plant. It is not suitable for the large power plant. The maximum, the outlet, it should be considered only for the 20 megawatts. The maximum, it should be considered for the 20 megawatts. The fire tube boiler is not suitable for the large power plant, and it occupies for more space because the internally fired, the external surrounded by the water. The external surrounded by the water. For that purpose, the space requirement is more, and the construction is very difficult in the fire tube boiler. Next, the boiler, the maintenance is also very difficult, and the transportation is also difficult because in the fire tube boiler, the weight is more. Due to that, the transportation is difficult. That is vice versa of the water tube boiler. Generally, in the all the power plant, the maximum they will be preferred for the water tube boiler. Here we can generate it up to the 500 megawatt. In water tube boiler, we can generate the power up to 500 megawatt. But in fire tube boiler, we can generate the maximum power up to the 20 megawatts. And one more thing, here the construction is difficult. In the fire tube boiler, the efficiency we are getting only for 80 to 85%. 80 to 85%. The remaining, the 50% in terms of losses, that is nothing but the flue gases. But in water tube boiler, the losses is only 10%, that is nothing but the flue gases. Again, we are reusing these flue gases through superheater, economizer, air preheater. The remaining in that, the 40 to 50%, it will be go out through the chimney. The main thing is nothing but the difference of the water tube boiler and the fire tube boiler. In water tube boiler, the water is flowing inside the tubes. Surrounded the combustion of the fire, surrounding the combustion of the fire. But in the fire tube boiler, the hot gas of combustion flow inside the tube surrounded the water. And this, the water tube boiler, it should be fired externally. But in the fire tube boiler, it should be fired internally. That is nothing but the internal fire. And the rate of combustion, the production is, the steam production is high in the water tube boiler because the surrounded the heat, the water is flowing inside the tubes. Due to that, the steam production is high. In fire tube boiler, the steam production is low, and it can be applicable for medium as well as for the large power plant. We can go for either 250 megawatt power plant or 500 megawatt power plant or 350 megawatt power plant. But this, the fire tube boiler, it is not suitable for the large power plant, but maximum it should be withstand up to the 20 megawatt. We can go up to 50 megawatt also. We can go up to 50 to 60 megawatt. But the main drawback is here the fire is internally fired. Due to that, the steam production is very less. And one more thing, in the water tube boiler, the space requirement is less, and the construction is also easier. The transportation is easy. Due to the less in weight. But in the fire tube boiler, the space requirement is more. The weight is also high. The construction is difficult, and the transportation is also difficult in the fire tube boiler. And the major drawback in the water tube boiler is it is easily accessible. That is, all the auxiliary parts are not easily accessible for cleaning, repair, and then maintenance. But here in fire tube boiler, this is the advantage. The various parts are easily accessible. This is nothing but the steam generating equipment consists of, the primary thing is nothing but boiler. The second one, superheater. Next, third one is economizer, and the fourth one is air preheater. Generally, in the boiler, the water is converted in the form of steam. Based upon the thermal power plant, there are two types of boiler. One is for the water tube boiler, another one is for the fire tube boiler. In the thermal power plant, the temperature is maintained from 250 degrees centigrade to 500 degree centigrade. 500 degree centigrade. We want to generate the power either 300 megawatt or 350 megawatt or 400 megawatt. The minimum temperature is required from 250 degree centigrade. Here, the boiler are classified for two types. One is for water tube boiler, another one is for the fire tube boiler. In water tube boiler, the water is flowing inside the tubes surrounded the fire. That is, here the three parameters are required. One is nothing but the air, another one water, next one is fuel. Next one is fuel. In the thermal power plant, the fuel we are using is the coal. The water we are using in the boiler. The atmospheric air is supplied through the air preheater to burn the coal fastly. To produce the steam, high pressure and then temperature. To produce the steam, high pressure and then temperature. You can observe here in that the water tube boiler, the water is flowing inside the tube surrounded by the fire. Due to that, the steam produced is more and the space requirement is less. The space requirement is less, and this generated steam drives the steam turbine through superheater. If directly strikes the without superheater, the turbine blades are damaged to formation of the corrosion. The blades are damaged due to the moisture. This is nothing but the wet steam. The small amount of the moisture particle is there. If directly drives means damaged the blades. Again, in the superheater, reheating the flue gases, that is the outlet. In that, the water tube boiler, the efficiency is 85 to 90%. 85 to 90%. The 10% of the steam is wasted in the water tube boiler. That wastage in terms of flue gases. That is, we are reheating the superheater, economizer, and air preheater through flue gases. That is, the wastage of the steam, we are reheating the superheater. In that, the superheater, it brings from the above boiling point. The next one is the fire tube boiler. In fire tube boiler, the water is the surrounding. The fire is burned for the internal. The surrounded the water. The fire is burned for internal. Due to that, the efficiency is less. It can be applicable only for 20 megawatts. It should be applicable only for the 20 megawatts. And now you can see the comparison between water tube boiler and then fire tube boiler. You can observe here the position of the water and then hot gases. In water tube boiler, the water is flowing inside the tubes surrounded combustion of the fuel. But in the fire tube boiler, the fire is flowing inside the tube. That is nothing but the internal combustion, the surrounded by water. Mode of firing. How it is the firing in the water tube boiler? The externally fired. The water tube boiler is the burning for externally, and the fire tube boiler, the internally fired, surrounded by the water. The next one, the operating pressure. And generally here the pressure is more in the water tube boiler in terms of 100 bar. But in the fire tube boiler, the pressure is less. It is nothing but the 60 bar. And rate of steam production. The water tube boiler, the steam production is high. In fire tube boiler, the steam production is low because the surrounded the water. Due to that, the steam production is very, very less. And another one, the suitability. Generally in the water tube boiler, the suitable for large power plant because the temperature is maintained from 250 degrees centigrade to the 500 degrees centigrade. But in the fire tube boiler is not suitable for the large power plant because here we are generating only for the 20 megawatt. We are generating only for 20 megawatt. And the space requirement, the water tube boiler, the space requirement is less. And the construction is also simple. The transportation is also easy due to the light in weight. But in the fire tube boiler, the space requirement is more and the weight is also more weight. Due to the more weight, the transportation is difficult. The construction is also difficult. And chances of explosion, the water tube boiler is less and the fire tube boiler is more. And the next the steam generating equipment. The first one is nothing but the boiler. The second one is the superheater. In the main function of the superheater is we are observing the moisture particle in that the boiler, the output steam, and improving the efficiency above the boiling point. That is, the superheater is a device which superheats the steam, that is, raise the temperature of steam above boiling point of water. This increases the overall efficiency of the plant. This increases the overall efficiency of the plant. Due to the superheater, we are using the flue gases, the superheater, economizer, and then air preheater. We are improving the efficiency, that is 5 to 10%. Actually, in the thermal power plant, the losses is 71%. The losses is 71%. In the boiler, losses is nothing but 16%, and turbine loss is nothing but 54%, and alternator is 1%. That is 71%. The efficiency we are getting for 29%. The efficiency is 29%. We are reheating in the intermediate stages due to the flue gases, superheater, air preheater, and then economizer. The efficiency can be improved from 5 to 10%. 5 to 10%. That is, the efficiency we can bring from 30 to 35%. The efficiency we can bring from 30 to 35%. That is, the superheater consists of the group of tubes made of special alloy steel such as chromium, molybdenum. That is, the superheater transfers the heat of flue gases by two methods. One is nothing but the radiant superheater. Another one is nothing but the convection or convective superheater. Convection or convective superheater. In the radiant superheater, this is nothing but the radiant superheater. That is, the superheater receives heat from the burning fuel through the radiation process. Through the radiation process, it is placed in furnace between the furnace water wall. Now, this is nothing but the furnace is there. In between the furnace water wall, they are kept for the superheater. Here, the major drawback is the dropping characteristics high, and one more thing, the temperature of the superheater falls with increase in the steam output. Steam output. But maximum all the power plant, they will be preferred for the convective superheater. The convective superheater means they receives heat from the flue gases in the convection process. This is nothing but the boiler furnace is there. The wastage in the form of flue gases, that is the 10%. We are using in the boiler water heater. The boiler water heater, that is 85 to 90% is the efficiency. 10% is loss in the form of flue gases. That is, we are reusing in the superheater, economizer, and then air preheater. In the convection process, we are heating with the help of the flue gases in the process of convection process. It is placed in the boiler tube bank. It is placed in the boiler tube bank. In the convection process, the commonly used raising characteristics, that is, the temperature of the superheater increases as with increasing in the steam output. In this, the superheater observes the moisture particle and improve the above boiling temperature. Due to that, the efficiency should be increased up to the 5%. Up to 5%. Here, the superheated steam drives the steam turbine with high pressure and then temperature. With high pressure and temperature through valve. This is nothing but the valve is there. After that, the valve we are using for the steam turbine. Based upon the demand, we are adjusting for the valve controller. Based upon the demand, we are adjusting for the valve controller. The superheater is classified for two types. One is nothing but the radiant superheater, another one is for the convection superheater. But in all the power plant, they are preferred only for the convection type superheater. Convection type superheater. The next one is nothing but the economizer. That is, from the boiler output in the flue gases, that is 10% wasting in the steam. That is, we are reusing in the superheater, economizer. Another one is for the air preheater. In that, the economizer, this is nothing but the fed water heater. Economizer is fed water heater. It is placed in between superheater and the boiler. Again, all the flue gases, the wastage of the flue gases, the complete 10% we are not utilized completely in the superheater. Only 2 or 3% we are utilizing. Remaining it will be goes through the economizer. There we are utilizing for 1 or 2%. And the remaining it will be goes through the air preheater. There it should be utilized 1 or 2%. Remaining it will be goes through the atmosphere through chimney. Now, in the economizer is nothing but the fed water heater. The water is heated from the flue gases. The water is heated from the flue gases. Here, the water it will be inletted from the cooling tower. The water is inletted from the cooling tower. That is, it should be maintained from some amount of temperature, that is 35 or 40, maximum up to 80 to 120 degrees centigrade. The water is carried from the tubes. The water is carried inside the tubes. Here, the flue gases it will be inlet and outlet. The flue gases it will be flowing the surrounding. In this, the tubes already the water is flowing. Due to that, the steam it is similar to the water tube boiler. The water is flowing inside the tube, surrounded by the heat. Due to this flue gases, again the water it will be bring from some amount of the temperature. Again, that hot water it will be outlet. It is goes to the boiler. It should be goes to the boiler. Now, by using this the economizer, we are improving the efficiency, that is 10 to 12%. We are improving the efficiency in the boiler. We are improving the efficiency in the boiler 10 to 12%. With this help of the economizer, the water is reheated and the temperature it should be bring from either 120 or 130 or 140 degrees centigrade in the water outlet. Due to that, the boiler efficiency should be increased from 10 to 12%. Once the boiler efficiency is increased, means automatically the fuel consumption is also minimized. The fuel consumption is also minimized. That is, the boiler the efficiency is increased from 10 to 12%. Due to that, the efficiency, the fuel consumption can saved from 5 to 15%. Once we are saving the fuel, that it will be utilized for the future. Generally, at present, day to day, the fossil fuels are depleted. The available, the fossil fuels are up to 2026. Almost all, we can go for the 40 to 50% of the power generation by using fossil fuel. In the year completely 2032 to 34, it should be depleted the maximum 90%. 90%. You can save the fuel by using intermediate, reheating the intermediate stages through superheater, economizer and air preheater. You can save the 5 to 15% of the fuel. It can be utilized for the future. That is tomorrow or day after tomorrow, future 1 month or future 1 year or 2 years. We can save the fuel. This is nothing but the economizer. And the next component of the steam generating plant is air preheater. The air preheater is placed in between economizer and then the boiler. The function of the air preheater is to extract heat from the flue gases and give it to the air being supplied to the furnace for coal combustion. By using this air preheater, with the help of the forced draft fan, collected the atmospheric air and given into the air to the boiler furnace. Here you can see here the air, it is the inlet, and the boiler furnace already the fuel gas from this the economizer. This is the tubes. The surrounding the fuel is burning. The inlet the atmospheric air we want to give. In atmosphere, always the climate is not same in a year 365 days. Based upon the season, the climate is changed. That is the rainy season, monsoon season, and the summer season. Some of the time in the rainy season, in the atmospheric air, the small amount of the moisture, the water particle is there. Directly it sent to the boiler furnace. The temperature is fallen suddenly. The temperature is fallen suddenly. Due to that, already in that the thermal power plant, the efficiency we are getting for 29%. Suddenly the temperature is reduced. Suddenly the efficiency is fallen, means again we are getting only 20% or 21 or 22%. Again, we are not satisfied for the consumer. For that purpose, that the air we can carry from the forced draft fan through sent to the boiler via air preheater. In the air preheater utilized for the flue gases, that air it should be bring from some amount of the temperature. Due to that, the efficiency should be maintained for increased, and the boiler efficiency is also increased, that is 2 to 3%. Due to that, the fuel consumption is minimized. Here there are two types is there. One is nothing but recapturative type, another one is for the regenerative type. Recapturative type means a group of steel tube, the flue gases are passed to the tube, the air flows externally to the tubes. Once the air it will be flowing externally, means nothing but the tubes is there, the air is inside. Now in the tube, the steam is flowing in the tube, the steam is flowing surrounded the air means again in the atmospheric air the temperature is reduced. In the regenerative type means inside the tube the air is flowing surrounded the flue gases, due to that the temperature is increased. Actually in that the thermal power plant they are preferred for the regenerative type air preheater. And the next one is nothing but the electrostatic precipitator. This is the major equipment in the thermal power plant. Actually the flue gases, the wastage is nothing but the 10%. In these flue gases the small particle of the fumes is available. Due to that it releases for the sulfuric oxide, another one is for the nitrous oxide. Sulfuric oxide, another one is for the nitrous oxide. Due to the sulfuric oxide it destroyed for the living organism and it should be destroyed for the leaves, so on, etc. The vegetable, so many things. And due to the nitrous oxide affected for the human being due to respiration problem, that is the breathing problem is arises. To avoid that one we are using for the electrostatic precipitator. The flue gases the 10% wasted, it goes to the superheater, again economizer, again air preheater. Even though 3 to 4% of the steam is wasted, that it will be goes through the chimney through natural draft fan. Here it polluted to the environment, the surrounding 10 to 15 kilometers. For that purpose the thermal power plant is constructed away from the populated area. With this the help of electrostatic precipitator, the primary collector as supplementary unit, the cyclone collector. Here whenever entering into the flue gases, in this the duct you can given for the additional again the charging DC supply is given. Due to that the fine particle it should be observed, again it should be discharged to the bottom of the furnace. Even though again the 1 to 2% it will be enter into the atmospheric air. And with the help of the electrostatic precipitator you can remove of the dust and ash particle carried with exhaust gas of in the particular thermal power plant itself. Again here we want to give for the DC supply in the particular electrostatic precipitator to operate that one. Then it should be going to the environment 3 to 4%. In that the more than 60 to 70% of the dust, the finite particle it should be observed. Due to that the minimize for the release of the sulfuric oxide and then nitrous oxide. You can save for the environment. And next topic is nothing but the condenser. Actually in that the turbine, the 54% of the steam is wasted in the turbine. The ejected in the turbine is nothing but the 54% of the steam. That steam is collected in the condenser. That vapor we can convert it in the form of water, that we can recirculate it to the cooling tower. Again that water we can reheat it, that send it to the economizer through fed water pump. By using this the condenser we can exhaust the steam used as a fed water for the boiler. There are two types of condenser is there. One is nothing but the jet type condenser, another one is for the surface type condenser. In jet type condenser means the cooling water and exhaust steam are mixed together. Now you can see this is nothing but fed water from the boiler and the steam is ejected. The both are merged means again the efficiency is fallen. The efficiency is reduced. Here the advantage is nothing but advantages in the jet condenser is nothing but the initial cost is less, the space requirement is also less, and the maintenance is less. But the major drawback is the condensated is wasted. That is the 54% is wasted. We are utilized in this only for the 10%. We are utilized only in the 10 to 15%. And if you go for the surface condenser, here it is not a direct contact between cooling water and then exhaust steam. The cooling water and then exhaust steam. Now this is the steam is injected. The water it will be flowing inside the tubes. The water is flowing inside the tubes. Due to that, the temperature is increased. The water temperature is increased maximum. The water temperature is increased maximum. The water it will be inletted. The water is flowing inside the tubes. Due to that, the temperature is increased maximum. And the major advantage of this, the surface condenser is we can improve the efficiency 5 to 10%, and the steam is not wasted. The water is flowing inside the tube, surrounded by the steam. The wastage of steam is nothing but 54%. In that, how much the efficiency of the boiler? Almost all, in that 60% of the steam is there. Suppose in the boiler output is, you can take 400 degree centigrade. 400 degree centigrade. Again, this 400 degree centigrade we are reheating in the superheater. The temperature is comes from the 420 degree centigrade. Thus drives the steam turbine. The ejected in the turbine is nothing but the drop is either 360 degree centigrade. Again, we are reheating. Maximum they are preferred in that thermal power plant surface condenser. The thermal power plant they are used is nothing but surface